Hello, I am Mustafa Wahba. I work in front-end web developer. In 2018, I have been in your position studying at Udacity front-end nano degree. It has been a great experience and opportunity for me. I graduated from it with lots of experience, knowledge, and lots of opportunities offered to me. So I highly urge you to enjoy experience at Udacity. It will be so amazing graduating from it. Today I'm going to discuss closures with you. Closures is a very harsh topic to grasp at first, but when understood in context with scope and first-class functions, it becomes so easy and so rational to get the hang of. We gotta first discuss first-class functions and scope in JavaScript. After that we be eventually ready to discuss closures. We cannot even discuss closures without the previous two topics because closures arise from them. So to start, we will go with first-class functions. What does it even mean for JavaScript functions to be first-class functions? Okay, JavaScript functions being first-class functions mean that they are equal to other JavaScript data structures, meaning that JavaScript functions are at the same level of JavaScript strings, numbers, and the other data structures. What does it even mean? Okay, JavaScript strings, for example, can be stored in a variable, can be passed as arguments, and can be returned from functions. And the same applies for JavaScript functions. JavaScript functions can be stored in variables, can be passed as arguments, and can be returned from functions. Let's see how JavaScript functions can be stored in variables in what's known as function expressions. In this example, you see that we stored the string Mustafa in the variable name, and we can retrieve the string using the variable name right here. Let's see it in action and executed, and Mustafa was printed out. This is how strings are stored in variables. And in this example right here, you see this is a function definition. Say hello. This is a function definition, not a function expression, function definition, and we can execute it using the function name right here, which is called say hello and parentheses. Let's see it in action. And hello was console logged. And in this example right here, you see that the function is not a function definition, it's an anonymous function stored in a variable. The same thing as it goes with strings. The function is stored in a variable and not a function definition, and there is no name right here. So we will use the variable name, not the function name, to try to invoke the function. Here it happens. Say hello is the variable name, not the function name. Let's execute it. And hello was printed out the same way with function definition. So this is called function expressions, and it goes the same way as function definitions. Now you have seen how function expressions or functions can act as strings in being stored in variables exactly the same way and invoked in the same way as function definitions. Now that you have seen how JavaScript functions can be stored in variables in the same way as strings, let's see how JavaScript functions can be returned from other functions. In this example, you see the string Mike stored in a variable called name. After that, the string value was returned from the function. Let's output the function return out to see what it is value. It's executed and console log that return value. It returns the string Mike. And now let's see what happens when a function is returned from another function. Here we have an outer say name function and an inner returned function, anonymous function returned from the other outer function. We have here a variable called first name and its value is Mike. the variable first name is used inside the inner function, the inner returned function, which is not executed until it is returned. So let's see that in action. We will try to execute the first function, say name. It returns a function definition as you see it. It is the inner function definition right here. So we need to execute say name twice. The first time to execute the outer function scope, the say name scope, and after that it will execute the returned function. So Mike was printed out. Note that the function that returns another function is called a higher order function. So say name is a higher order function because it returns another function. And with returned function you have two options. You can execute the outer higher order function twice, the say name function, you can execute it twice as we did right here to execute the inner returned function, or you can store the returned function in a variable. Instead of executing say name twice, we can do that. Let x, for example, equal say name, and that's how we store the returned function inside of the variable x. So this function now is recorded in the variable x, and that's how this function jumped out and it changed its context to be inside the variable x. And this point is very important to closures, and this is how closures arise. And also functions can be passed as arguments to other functions and executed from there, and we call it delegated function execution. That helps in what's called composition. Of course, you have seen this behavior in methods like for each, map, and filter. In passing functions as arguments, you can pass the function name, the function variable that holds the function expression, or you can pass the function definition itself inside the parentheses. Okay, let's see that in action. First, let's see how normal data structures in JavaScript are passed as arguments. Here we have a function and we are invoking it with arguments. Let's execute it to see how these two arguments are added together and returned after function execution. Let's see that in action. And 5 was returned from the function. 2 and 3 are passed to the function, and the sum was returned. The same behavior happens with functions, as they can be passed as arguments the same way as other data structures in JavaScript. Functions passed as arguments in JavaScript are called callbacks, as you see callback function right here. And also the function receiving callback functions as arguments is called a higher order function. So call and add here, right here, is a higher order function, and callback function here is a callback actually. Okay, so call and add function is invoked right here with two arguments. The first of them is 2 and received in the function as the parameter n, and the second argument is return 3, which is received in the function as callback function parameter. Return 3 is a function definition found right here, which returns the number 3. So we actually passing the function definition return 3 right here into the call and add function right here. And that's how we pass function definition into a higher order function. You see right here the callback function is executed from inside the higher order function, and that's delegated function execution. Let's execute the code and see it in action, and it returns 5. How that happens? Okay, call and add function is executed and passed 2 and return 3. Return 3 function, this function definition is passed to the higher order function, both of them. So n right here equals 2, and the callback function equals this function definition, which when executed right here returns 3. So n, which equals 2 plus 3, the returned value from the callback function, which equals 3, yeah, both of them equal 5, and this is the return. And instead of representing the function definition with the function name right here and passing the function name at the argument return 3 right here, we can pass the whole function definition inside parentheses. Let's see that in action. Let's delete this return 3 function name right here and replace it with the function definition. And executing, it worked. Both of them is true. Actually, this behavior right here is the same behavior which happens with for each map or filter method. Now that you have seen how callback functions work, it's the time for a little quiz. In this problem, what is printed to the console right here? Take 10 seconds to think about it. Okay, let's try it in the console and see what is printed actually. On execution, 24 is printed to the console. Let's see how did that happen. Let's start from the invocation. Multiply function was invoked right here, passing it the first callback and second callback functions. Those function definitions were passed to be executed right here. Upon executing the first callback function, 6 was returned. Upon executing second callback function, 4 was returned, and 6 multiplied by 4 equals 24, and that's why 24 is printed out. Until now, we have seen how JavaScript functions are first-class functions, meaning that they can be passed as arguments, they can be returned from functions, and they can be assigned to variables. And these three techniques make the underlying principle behind closures, as they make what I like to call jumper functions, JavaScript functions, as I like to call them jumper functions. Functions that is defined in one context and can be transmitted to another different context and executed from that different context. That is created by first-class functions, the ability and capability of JavaScript functions to jump. So now we are ahead to speak about scope and closures, but that will happen in the next session. It was amazing being with you today, so thank you for having me for today. See you later.